statements. Jump statements will help you to transfer the control from one part of the program to another part. Jump statements in Java helps the programmer to transfer the control from a part of the program to another part. Okay. There are two jump statements in Java. They are continue and break. You might be familiar with the break statement. We have been using break statement with switch case structure. In switch case structure, to transfer the control from the matching case to the following cases of the switch case, to the following statements after the switch case, break command was used. What happens in switch case if break command is not used after the matching case? In each case, a situation called fall through arises if break command is not given after each case structure. When a matching case is encountered, control falls down to the following cases without checking any condition. So you are familiar with the use of break command in switch case structure. Today we will learn how to use break command and continue command with looping structures. There are two jump statements in Java. They are continue and break commands. We have two more other commands which are used to transfer the control unconditionally. One is return statement, the other one is system.exit command. Return statement is mainly used with functions, whereas system.exit command will stop the execution of the program. It stops the execution of the program. So mainly break and continue statements are known as jump statements in Java. This question was asked once for ICSE board exam, a 2 marks question. Name the jump statements in Java. They are break and continue. Today we will learn how to use break and continue with looping structures. How do they function when break and continue are used in looping structures? These two statements or commands are known as jump statements in Java. There are two more statements used to transfer the control unconditionally from one part of the program to another part. They are return command and system.exit 0. System.exit 0, this command. And return command, you will learn about return command when you learn functions. Okay. Return command is used with the functions to transfer the control from a function to the main function or to the calling part of the function. System.exit command stops the execution of the program without checking any condition. Mainly, break and continue are known as jump statements in Java, even though they are also used for transferring the control from one part of the program to another part. These two are known as jump statements in Java. Jump statements are used to transfer the control from a part of the program to another part. Let us see how these two commands work when they are used with looping structures. First of all, let us see how break command works with looping structures. Let me give you an example. Let me give you the syntax for using break command with different looping structures. Which are the looping structures that we have studied? For loop, while loop and do while loop. For loop and while loop are entry controlled loops, whereas do while loop is an exit controlled loop. For loop and while loop, Entry into the loop's body is only after checking a condition. If the test expression evaluates to true, control enters into the loop's body. Whereas in case of do while loop, loop's body executes at least once without checking the test expression. Test expression is checked or tested at the bottom of the do while loop. Okay. Let us learn how to use break command, how break command works when they are used in these looping structures. Let us see the syntax first. For initialization, test expression, updation. Updation statement, and then the loop index variable is initialized. Condition is tested to determine whether the loop's body has to be executed or not. After executing the loop's body, updation takes place and control comes back to the test expression to evaluate it to determine whether the loop has to be iterated or not. So there are a number of statements given inside the loop's body. Statement 1, statement 2, statement 3. A number of statements are given. After that, break command is given. Break. After the break command, some more statements are given. Statement 4, statement 5, statement 6. Some more statements are given after the break command, and loop's body is closed. Loop's body is closed. So, index variable is initialized, loop index variable is initialized, condition is tested to determine the loop's body has to be executed or not, and then if the test expression evaluates to true, control enters into the loop's body. Control comes to the loop's body. Statement 1 gets executed, statement 2 gets executed, and 3 also gets executed. After that, the following statement is break command. When a break command is given, control goes out of the enclosing in which the break command is given. It goes out, control transfers outside of the looping structure in which the break command is given without executing the remaining statements within the body of the loop. Okay. By skipping statement 4, 5 and 6. Okay. So statement 4, 5 and 6 will not be executed as break command is given here. So when break command is given inside a for loop, whatever statements are given before the break command will get executed. As the break command is encountered, control goes out of the for loop, and the following the commands given within the body after the break command will not be executed. So here statement 1, 2 and 3 will be executed. After that, break command is encountered. So control goes out to the following statements of the for loop and leaving or skipping statement 4, 5 and 6. Statement 4, 5 and 6. Okay. So let us see one example. Let me write a for loop to demonstrate it, to make you understand this particular structure in a better way. For int I equal to 1, I less than or equal to 10 plus plus I. If I equal to 5, break, else system dot out dot print line I. int I equal to 1, or simply else path we can avoid if you are using this system.out.println statement here. System.out.println I. If I equal to 5, break. So this why I have written like this is to show you that this particular part or set of statements will be skipped. Okay. Initially, I is equal to 1. I less than or equal to 10. Yes. So, here we are checking a condition. If I equal to 5, go out of the loop. I is not equal to 5. So, the value of I is printed. 1 is printed on the script. Updation takes place. I get the value of I is updated to 2. 2 less than 10. 2 is not equal to 5. So, 2 is printed. Then updation takes place, 3 is less than 10, 3 is not equal to 5, so 3 gets printed. Okay. Updation takes place, 4 is less than or equal to 10, so 4 is not equal to 5, 4 gets printed. Now 5 is less than or equal to 10, so control enters into the loop's body. Here 5 equal to 5, yes, so control goes out without checking anything. So we will get the values printed 1, 2, 3, 4. When it is 5, without executing the following part, control goes out of the for loop. Okay, this is how a for loop works. Let us do one program with a for loop, with a break command. This program is from your textbook. Before going to that, let us see what is the syntax for using break command with while loop and do while loop. Syntax for using break command with a for loop is like this. For initialization, test expression, updation, and a number of statements are given within the body. After that, a break command is given. And after the break command, inside the body, there are some more statements to be executed. But when break command is encountered, statement 1 will be executed, statement 2 is executed, and 3 is also executed. When break command is encountered, control goes out of the for loop, skipping all the 3 statements given inside the body. All the remaining statements inside the body, in between the break command and the closing of the loop's body, will be skipped, and control transfers out of the looping structure when break command is encountered. This is how break command works when it is used with a for loop. Now let us see what is the syntax of using break command with a while. While test expression, statement 1, statement 2, statement 3, break, statement 4, statement 5, statement 6, this is the syntax of using break command with a while loop. So while loop is also an entry controlled loop. Loop index variable will be initialized before the loop, and variable will be tested to determine whether the control has to be entered into the loop's body. If the test expression evaluates to true, statement 1, 2, 3 get executed. When the break command is encountered, without executing S4, S5 and S6, control goes out. In the same way how it works in for loop, in the while loop also, when break command is encountered, control goes out of that loop. Unconditionally, it goes out of the loop. Okay. Now let us see what is the syntax of using break command with a do while loop. Do a set of commands, execute a set of statements, break, S4, S5, S6 while test expression. While test expression. So, do while loop executes its body at least once without checking the condition. So, as we entered into the loop's body, statement 1, 2, 3 gets executed when break command is in, control goes out. Without executing statement 4, 5 and 6. This is the syntax of using break command within do while loop. So, when break command is given within a looping structure, control transfers outside of the loop unconditionally by skipping all the statements given after the break command within the body of the loop. Let us do one program. This program is there in your textbook. Question is like this. Write a program to print 20 terms of the series. Series is given like this, 3n plus 2. Stop as soon as multiple of 4 is encountered. Question is like this. Let me write the question on the board. Write a program to print. Write a program in Java to print. Write a program in Java to print 20 terms of the series Each term in the series is obtained by 3n plus 2 by using the formula 3n plus 2. Stop as soon as the multiple of 4 is encountered. Stop the program execution as soon as a multiple of 4 is encountered. Okay. So, how to write the program for solving this problem to get the terms of the series printed? Let us start. Public class, class name. Here you don't have to, you can enter the value for n from the keyboard. There's a provision to enter value for n from the keyboard. Here in this expression, 3 is constant, n is a variable and 2 is also constant. A term of the series is obtained by using this particular formula. So, for the variable n, you can provide value. You can accept the value from the keyboard and you can increment it by 1. Let us assume n as 1 for this particular instance. Let me assume the value for n as 1 initially. Okay. So, public class test, I am not going to accept the user input in this case. In this case, I am not going to accept the user input. So, I need not use scanner class in my program. So, I am going to start defining the class. Public class series, give a meaningful name, series. Public class series, public void main, or any name can be given by you. Public void main or display or any name can be given. Public void main for the method, and variable n should be assigned with the value. So, and each term of the series should be calculated by using this formula. Okay. 20 terms of the series should be printed, but when a multiple of 4 is encountered, control should go out of the loop. It should stop the program execution. Okay. So, that is the condition. So, to store the value of n, variable n is declared as integer, int n, to store each term which is calculated by using this expression. Term, a variable term is also declared. If when you compile this program, if it shows any error message, you have to convert the data type of term as long. Okay, if there is any problem for precision, convert this data type to long integer. Okay. Let n equal to 1. And let me use for loop. We are going to display the first term, 4. Okay, let me use n as the index variable. N itself as the index variable of for loop. So let me initialize n inside the loop. N equal to 1, n less than or equal to 20 plus n. I think in your textbook the variable, loop index variable used is I. Doesn't matter. It's up to you, you can use any variable. Term equal to, term is calculated as 3 into n plus 2. 3 into n plus 2. Now we have to display the term. All the terms need not be displayed. Only the terms which are not the multiples of 4 should be displayed. Only the terms which are not the multiples of 4 should be displayed. How to check whether a term is a multiple, whether the obtained term is a multiple of 4? If the obtained number is a multiple of 4, it will be divisible by 4. So, remainder of the division should be taken. Term modulus 4 is equal to 0 means this particular term is divisible by 4. So, this term is a multiple of 4. If term modulus 4 is equal to 0, break. We don't want the multiple of 4 to get printed. Otherwise, system.out.println term. Body of the loop is closed and method is closed. Method is closed, class is closed. Let us see how this program works. Let us see how this program works. In the end, variable n is declared, n term n is initially 1. We need 20 terms. As we know, there are 20 terms. I am going to use for loop. So, we are going to count as term 1. 1 less than or equal to 20. Yes, 1 less than or equal to 20. Yes. Term equal to 3 into 1 plus 2. Term equal to 3 into 1 plus 2. 3 into 1 is 3, 3 plus 2 is 5. 5 modulus 4 is equal to 0. 5 is not divisible by 4. So, 5 is not a multiple of 4. So, 5 modulus 4 equal to 0. No, it is not equal to 0. So, break command will not be executed. Following command will be executed, that is system.out.println term. Term, we get the output on the screen as 5 printed. 5 printed. And control goes to the beginning, to the updation statement. N becomes 2. N is 2. 2 less than 20. We are at the second term. Term equal to 3 into 2. Term equal to 3 into 2 plus 2. That is 6 plus 2, 8. 8 modulus 4 equal to 0. 8 modulus 4 equal to 0. If term modulus 4 is equal to 0, yes, 8 modulus 4 is equal to 0. 8 is divisible by 4. So, 8 is a multiple of 4. So, what happened? Break command is given. control goes out of the for loop without executing system.out.println term. So we will not get anything printed on the screen, control goes out of the for loop. So when we encounter a multiple of 4, control goes out. If term modulus 4 is equal to 0, break. So control goes out of the for loop to execute the following statements after the for loop. As there are no more statements given after the for loop, control goes out, program execution stops. So we will get the output printed as 5. Only 5 will be printed. 20 terms of the series will not be printed. As the second term of the series is 3 into 2 is 3 into 2 is 6, 6 plus 2 is 8. 8 modulus 4 is equal to 0. Control goes out. So only once this loop gets executed. It gets executed twice, but result will be printed only once. Control enters into the loop's body twice, but output printed only once, because second time it's a divisible, the term is a divisible of 4, so control goes out of the looping structure. So you will get the output printed on the screen as 5. Okay. I think it's clear for everybody. Now let me move on to second program. With break command, let me learn how to use break command with one more program. Here in this program I am going to use break command with a while loop. Question is like this. I think this program is also there in your textbook. It's a program from your textbook. Write a program to print a number, to input a number and check whether it's a prime number or not. Write a program to check whether a number is a prime number or not. User is asked to enter a number from the keyboard and the program checks whether it's a prime number or not. Let me write the question on the board and explain you what's a prime number. Second program, write a program in Java to check write a program in Java to input a number and check whether it's a prime number or not. All of you might be knowing, you might have learned in maths classes, like what's a prime number, what's a composite number, what's the difference between prime numbers and composite numbers. A prime number is a number which has only two factors, 1 and the number itself. It doesn't have any other factors. All the numbers which do not have any other factors other than 1 and the number itself are called as prime numbers. For example, 3 is a prime number. 3 is a prime number. 3. It has only two factors. They are factors. Factors are 1 and 3. 3 doesn't have any other factors other than 1 and 3. So 3 is a prime number. And another example, 11. Let us take another example. 11. 11 has only two factors. Factors are 1 and 11. It doesn't have any other factors. So 11 is a prime number. Whereas when we take 15, let us take the example 15. 15. And which are the factors of 15? 1 is a factor. Factors are 1. 1 is a factor. And 15 is it divisible by 2? How will you find out the factors of a number? We will take all the numbers from 1 onwards till the number and we will divide the number, and whenever you get the remainder as 0, you will consider that particular number as the factor of divisor, as the factor of dividend. Am I right? So 15 has the first factor as 1. 15 is it divisible by 2? No. So 2 is not a factor of 15. 15 is it divisible by 3? Yes, 15 is divisible by 3. So 3 is a factor of 15. And is it divisible by 4? No. Is it divisible by 5? No. So it doesn't have, is it divisible by 5? Let us see. 15 is it divisible by 4? 15 modulus 4 is equal to 0? No. Whereas 15 modulus 5 is equal to 0? Yes. So it has one more factor, 5. 1, 3, 5. Now 15 is it divisible by 6? No. 15 divisible by 7? No. 8 divisible by 8? No. Divisible by 9? No. It doesn't have any other factors other than 15. Look at, now we have got 3 factors for 15. 1, 3, 5 and 15. 1, 3, 5 and 15. What's the definition for prime number? A prime number has only 2 factors, 1 and that number itself. It will not have any other factors other than 1 and that number itself. Okay, so 15 is not a prime number. It's not a prime number. So you are asked to enter a particular number and check whether the given number is a prime number or not. What process we are going to do is, we'll take all the numbers from 2 to the half of the given number and we will divide the entered number by all these numbers. And whenever you get the remainder as 0, we can assume that the divisor used is a factor of the entered number. Okay, so in that case, the entered number is not prime. Okay, let us write the program and see how it works. So in this case, you are asked to input a number from the keyboard. To input a number from the keyboard, we are going to use scanner class. So import java.util.star to use the scanner class in the program. Now define the class, public class prime, public class prime number, public class prime number, class name started with capital letter, following word, there are 2 words in the class name, the second word also began with capital letter. There is no space given between the words. Okay. Public class prime number. Now method we have to define, isn't it? Public void, any meaningful name can be given for the method. Public void test. To accept the number, we need a variable. Let it be n, int n, and In our program, we are going to check whether a given number is prime or not. We are going to find out whether it has any factors or not. When we find that this given number has a factor, we will set a variable as true. I am going to declare one Boolean variable for that purpose. We are going to check whether the given number is divisible by any other number or not. If the number is divisible by any other number, our prime test will be false, otherwise it will remain with true. Let us see. Okay. So one more variable, a Boolean type variable, prime test. I am using the same variable as it is given in your textbook for your convenience. Otherwise, usually we used to use the variable flag, a variable with the name flag. Okay. So here in your textbook, the variable specified is prime test. Prime test. Prime test equal to initially true. We assume that the entered number is a prime number. Initially, we assume that the entered number is a prime number. So we set the prime test as true. It's a Boolean variable. And if we find that there are some factors for the entered number, then we will change this prime test to false. We find that the entered number is not a prime number, so we will make it as false. Okay. Now, we don't have to divide. 1 and the given number is a factor of all the numbers that we know. So we have to check whether 2 is a factor of the given number, 3 is a factor of the given number, 4 is a factor of the given number. Okay, isn't it? Likewise, take all the numbers, all the integers from the divisors. Take the divisors from 2 to the half of the given number. Okay, and divide and check whether you are getting 0 as a remainder at any time. Okay, so let us take the divisors, start taking the divisors from 2 onwards. Okay, so I am going to use a loop for that purpose, and loop index variable I, int I. Here itself you can declare comma I, so you can avoid the repetition. I equal to 2, and divisors should go till the half of the given number. We have forgotten one thing. Divisors when we take, I have told you that it should, we have to take the divisors from 2 to the half of the given number. Before taking the half of the given number, we should enter the number. Am I right? So, to accept a number from the keyboard, we have to define scanner class subject, and we should accept prompt to the user to enter the number. Am I right? Yes. So before initializing the loop index variable, let me define the scanner class. Object scanner type SC equal to new scanner system.in. Accept the variable, accept the number from the keyboard. System.out.println, enter a number. Enter a number. This number should be stored in n. N equal to sc.nextInt. sc.nextInt. So we have accepted the number from the keyboard. Now we should start dividing the entered number n by all the numbers from 2 to the half of n. Okay. So I am going to use while loop for this purpose. Loop index variable should be initialized. In while loop, index variable should be initialized before the while loop. So I equal to 2. 2 onwards all the numbers I am going to take as divisor. And mid, we don't have to imagine that when we take 20 as the input value, 20. Factors of 20 are 1, 2 is a factor, 3 is not a factor, 4 is a factor, 5 is a factor, 6 is not a factor, 7 is not a factor, 8 is not a factor, 9 is also not a factor, 10 is a factor, and 20 is a factor. We don't have to consider this 1 and 20. Now let us closely look at those factors. Factor starts from 2 and the highest factor is half of the given number. N is 20. N is 20. And the highest factor other than the given number is, highest factor obtained other than the given number is n by 2. N by 2. N by 2. That is 20 by 2. That is here 10. So by considering that, we are going to take all the numbers from 2 to the half of the given number. Okay. For that purpose only, half of the given number is calculated. Mid equal to n by 2. The highest factor other than the given number will be number divided by 2. By considering that particular aspect, we will be taking the divisors from 2 to the half of the given number. Okay. Now let me write the looping structure. For while loop, let me use while loop. While I less than or equal to mid, divisors should be taken from 2 to the half of the number. I less than or equal to mid, if n modulus let me write this looping structure at the other side for the convenience. While I less than or equal to mid, I less than or equal to mid, do the following statements. If n modulus I equal to 0, n modulus I equal to 0, entered number is divided by the initial value of I is initially 2. If n modulus I equal to 0 means I is a factor of the given number. So we found a factor other than 1 and that number itself. So it's not a prime number. So we have to assign prime test as false. Okay. So if I is a factor of n, we will get the remainder as 0. So we will assign prime test as false. We found that the entered number is not a prime number and we should transfer the control outside of the looping structure. Break command. We have taken the first divisor as 2. Number is not divisible by 2. So what we have to do? We found that 2 is not a factor of n. So we should move on to the next divisor. 3. We should take the next divisor, 3. 3 less than or equal to the entered number, yes. So n modulus 3 equal to 0, no. So we have to check whether 4 is a divisor of, whether the entered number is divisible by 4 or not. That process should continue till the half of the given number. Okay. So if n is not divisible by I, that means I is not a factor of n. We have to update n. Update I. Index variable is incremented. Plus I. And body of the while loop is closed. Body of the while loop is closed. Body of the while loop is closed. Outside the while loop, whenever we find I as a factor of n, this prime test will be false and control goes out of the while loop. Okay. So, if you find a factor for n other than 1 and the given number, prime test will be false. Now, when you come out of the looping structure, you have to check the value of prime test, whether it is true or false. If it remains with the true means, you did not find any other factor other than 1 and that number. Okay. From 2 onwards till the half of the number you have taken all the numbers as divisors, but you never found a factor for the given number from 2 onwards till the half of the number. So, it remains with the true. Otherwise, whenever you find a factor, prime test will be assigned with the value false. So, now we are going to check whether prime test is remaining with the true or false. According to the value of prime test, we will assign whether, we will assume whether the entered number is a prime number or not. Let us see with some examples. Let me complete the program first. If prime test equal to true means, if prime test equal to true means, entered number is a prime number, otherwise not a prime number. System.out.println, entered number is a prime number. Else system.out.println, not a prime number, not prime. Method is closed, class is closed. Now let us see how this program works with various inputs. As there is no space, here I am going to erase the question. We will see the dry run. Let us check whether 17 is a prime number or not. Let us check whether 17 is a prime number or not. We all know that 17 is a prime number, isn't it? So let us check when the user enters 17 how it works. Input n equal to 17. N is 17. Imagine that user has entered the value 17 as input. N is 17. N has got the value 17. I is equal to 2. I is initialized as 2. We have to take all the numbers from 2 to the half of 17. Mid equal to 17 by 2. Mid equal to 17 by 2. Integer division. It's integer division. 17 is integer, 2 is integer. So, integer division. Question is 17 by 2 is 8. Isn't it? 8. It's not 8.5. It's 8 because 17 is integer, 2 is also integer. Okay. So, mid is 8. So, we are going to take all the numbers from 2 to 8 as divisors. And we are going to divide 17 by 2 and check whether 2 is a factor of 17. 17 by 3, 17 by 4 till 8. Okay. So, I is equal to 2 initially, mid is equal to n by 2, 17 by 2 is 8. Now, while I less than mid, I is 2, 2 less than or equal to 8. Yes. 2 less than or equal to 8. Yes. N 2 less than or equal to 8. So, control enters into the loop's body. If n modulus I equal to 0, n is 17, 17 modulus 2 is equal to 0. No, 17 is not divisible by 2. So, no. Prime test, this particular set of commands will not be executed. Prime test is not assigned with false. Break command also will not be executed as n is 17 is not divisible by 2. 2 is not a factor of 17. So this part will not be executed. So what takes place next? Plus plus I. I will be incremented to 2. At the second iteration, I is equal to 3. Initially it was 2, it will be incremented to 3. 3 less than, next step, 3 less than or equal to mid. Mid is 8, isn't it? 3 less than or equal to mid. 3 less than 8, yes. So 17 modulus 3 equal to 0. Next step is 17 modulus 3 equal to 0. 17 is it divisible by 3? No. It's not divisible by 3? No. So the set of commands will not be executed. Plus plus I. I becomes 4. 4. Control goes to the beginning of the while loop. This is the closing of the while loop. Closing of the while loop. So 4 is not less than or equal to 8. 4 less than or equal to 8. Yes. 17 modulus 4. 17 modulus 4 equal to 0. No. No. So plus plus I becomes 5. 5 less than 8. 5 less than 8. Yes. So 17 modulus 5 equal to 0. No. So this particular part will not be executed. I is incremented to 6, becomes 6. 6 less than or equal to 8. 6 is less than 8. So control enters into the loop's body. 17 modulus 6 equal to 0. False. Plus plus I. Value of I becomes 7. 7 less than or equal to 8. Yes, condition satisfies. Value of n is 17. 17 modulus 7 equal to 0. No. So this particular segment will not be executed. Again I will be incremented to 8. 8 less than or equal to 8. 8 less than or equal to 8. Yes, 8 is equal to 8. So 17 modulus 8 equal to 0. No. No. So this part is not getting executed. This part will not be executed. Plus plus I. Value of I becomes 9. Now control goes to the beginning of the looping structure. Here 9. 9 less than or equal to 8. 9 is not less than or equal to 8. So control comes out of the loop. Control comes out of the loop to the following statement. If prime test equal to true, this part never got executed as we did not find any divisor for n. We took all the numbers from 2 to 8 for the variable I and we divided. We never found we never got the remainder as 0. That means that no values from 2 to 8 are the divisors of the entered number 17. 17 doesn't have any factors other than 1 and 17. So control came out. Prime test remains with the value true. Initially we set the value as true. So here we are checking prime test equal to true. Yes. So entered number is a prime number. This part will not be executed. Closing of the loop's body and class is encountered. Program execution stops. Let me explain with one more example. This is an example with a prime number when the user enters 17 as the input value. Let me take one example which is not a prime number and check how it works. Let us take a small number 6 for the convenience. Imagine that the input value for n is 6. Input value for n is 6. N is 6. Here the user entered the value for n as 6. And so we have to take all the numbers from 2 to the half of the entered number. I is initialized as I is equal to 2. Mid of n is calculated. Mid equal to 6 by 2, that is 3. So the looping structure will be like this. While I less than or equal to 3. Value of I less than or equal to 3. So initially now value of I is 2. 2 less than or equal to 3. Yes. 2 is less than 3. N, value of n is 6. 6 modulus 2. 6 modulus 2 equal to 0. Yes. 6 modulus 2 equal to 0. Here 6 modulus n is 6. N is 6. 6 modulus value of I is 2. 6 modulus 2 equal to 0. Yes. So what happened? When this condition evaluates to true, control enters into the loop, if structure. So the statement gets executed. Prime test equal to false. So initially we set it as true. Now as we found 2 as the divisor, 2 as the divisor of 6, 2 as the divisor of 6, 2 is a factor of 6, isn't it? So we need not check whether 3 is a factor of 6 or not. Already we found a factor which is other than 1 and the given number. So there itself we can stop, okay. So we found 2 as a factor of 6. So 6 has one more factor other than 1 and 6 which we found, okay. So 6 is divisible by 2, condition satisfies. Prime test will be assigned with the value false. Next statement is encountered, break. Break command when it is given within a looping structure, control goes out of the looping structure. So control comes out of the while loop, following statements will be executed. So prime test here it is assigned with the value false, isn't it? So as we found a factor, so when here it is checked prime test equal to true, no, false. So else part will be executed and not a prime will be printed. So 6 is not a prime number. As we found the first factor itself, we came out of the looping structure without continuing the loop. This is how a break command works when it is given inside a while loop or for loop. Hope everybody understood. If you have any doubts, you can contact me personally. This program is given in your textbook.